Okay, so as we are 3 minutes past the start of the meeting, I think we can slowly begin, and the other will join us on the way. So before we formally start this meeting, I would like to shortly present you the agenda of it. So I will start with a very, very brief presentation, introductory presentation to the project, and then I will pass the floor to our guests, our expert guests. Today with us we have Chris Buckridge from RIPE Network Coordination Center, Adam Peake from Internet Corporation for Assigned Names and Number, shortly ICANN, and Olaf Kolkman from the Internet Society. So, as I say, I will start with the short presentation. Sorry for not introducing myself. My name is Emilia Zalewska. I am from the Youth SIG Poland. And our organization, together with 2 other youth initiatives, Youth Coalition on Internet Governance and Youth Observatory, the youth chapter from Internet Society, we have the pleasure to be this year's Youth Summit co-organizers. And the part of the preparation to this Youth Summit is Project Youth Summit that you are all right now part of. Just please give me a moment to display the presentation, so it will be easier for me to illustrate what I'm talking about. You are able to see my screen right now. Just please give me a quick answer, yes or no.
Yes.
Right, thank you. Okay, so first of all, I would like to welcome you on behalf of our co-organizing team to the Project Youth Summit. Big congratulations for getting admitted here, because the general level of application was extremely high. So big kudos to you on delivering such outstanding applications. We are very, very happy to have you all on board. And I'm absolutely sure that we're gonna achieve amazing things together. And as you already know, we are having 8 working groups in total. You have already been assigned to the particular working group and contacted by your coordinator. And in those groups, you will work until the end of the project in December. And just very briefly, what we see as the project results. So I will start a bit from the end of the whole thing. So as the main goal of the whole project, we see points of action. What are they? During last summit, there were some very good, very innovative messages produced. And this year, we would like to use those messages as a base for our work and to move one step further into more specific proposals of solutions, of postulates, how young people could get more involved into the policy making, especially in the internet governance environment. So that's why we would like those points of action to include answers to 3 questions. So first of all, to define what is the challenge, where's the problem. Then thinking about the proposal for the problem, the ideas, how could it be solved. And then as the third aspect, we would like you to consider doing working in groups, who could help in solving it. So which parties, which stakeholder groups? Is it, for example, government, the party who could help, or private sector? So we would like those points of action to be very specific. Also, as one of the results, we see the shorter versions of points of action, so the easier ones to be presented. in the forms of slogans that will be easy to memorize. And then, while preparing those points of action, you for sure will do a lot of brainstorming, research, etc. So we would like to include all of this work and its results in the background, or policy papers, in which you will include your methods, the reasons why you chose particular challenge. So it will help us to prepare a final report, about which I will say more while showing the next slide. And here you've got a very brief timeline of the whole project. So now we are at the first step, the general meeting with our guest speakers. Then you will work in your working groups. I guess each working group will have a little different timeline, because it will be agreed with you and your coordinator. And then in the second week of November, there will be the second general meeting, during which you will have an opportunity to do some networking, to exchange comments. Each group will present what they have done so far. Then at the first week of December, there will be an open event, during which you will have an opportunity to present your work to the bigger audience, and especially of young people who couldn't or who didn't know about the project, but who would like to have their voices, their perspective included in our outcomes. So this will be the event during which you will have an opportunity to listen to other voices, to have some discussion with people who would attend this event. And after that, there's the grand finale of the whole project, the Youth Summit event. That will be at the day zero, on the day zero of the IGF, during which there will be a final presentation of the points of action by each group. And it will be a very big event. And also there will be some high-level guests, like from European Commission or United Nations, and also Polish government. So the audience will be really spectacular. And to this audience, you will have the opportunity to present your work. So I think it's a very, very big opportunity to get more attention to young people's voices. And after that, after the whole project, we would like to invite you to create final report, which will sum up the whole work, which will include those points of action, but also observations that, for example, will be made during the IGF or after the Youth Summit. And here you've got some social media where you can find the project. I recommend you following at least one or two of them. So you can find the project on Facebook, Twitter, LinkedIn, Instagram. Look for this logo you have in the bottom right corner. This is our project, and there will be also some updates there. And yeah, thank you very much for deciding to join us, and we hope that we will have a very fruitful cooperation together. And with this, I would like to pass the floor to our guest speakers, who will introduce us to the topic, how does the internet work? So I think it will be a very good opportunity to dive deeper into the more technical layers of the internet, which I guess a lot of people are not even aware of. So I think it's a take chance and don't hesitate to ask questions if you have any to our guests. And with this, I would like to pass the floor to our guests.
Thank you, Amelia. It's great to be here. My name is Chris Buckridge. I work for the RIPE NCC, which is an organization I'll talk a little bit more about in this presentation and hopefully give you a bit of a sense of what we do. First, yeah, I want to echo Amelia's point. Congratulations on getting into this program and doing this work. I think it's a really important part of the IGF that brings youth more into the discussion. What Olaf and Adam and myself are hoping to do today is give you a bit of background on the technical underpinnings of the internet. Amelia, in one of her slides there, had a number of different areas that internet governance, and it's a really diverse range of topics that make up internet governance. But behind all of that, sort of underlying a lot of these discussions, is the reality of the internet itself, the architecture that has made the internet so successful and that really represents something that is changeable, but is sort of has to be recognized by policymakers and by governance as it goes forward. Now, the way we've decided to do this, and we've done this previously, is to look at three sort of distinct areas of the technical underpinnings. Basically, I'm going to look at the Internet Protocol and IP addresses. Olaf is going to look at routing, which is how you move information between those addresses. And Adam's going to talk a bit about the domain name system, which is the URLs and domains that sit on top of that layer and make it all a little bit more usable by people. So I'm going to share my screen here because I have a few slides. Okay. So I've called the presentation Numbering the Global Internet, and it's talking about the Internet Protocol, IP addresses, and Internet governance. I'm just going to try and move this. Okay, sorry, I'm going to have to just do this 1 second. So I want to start with a bit of an assertion here, is that the Internet Protocol is everywhere. Essentially, what we know as the Internet is defined by the fact that it is a network of connections made via the Internet Protocol. An IP address is essentially what defines an Internet connection. And so an IP address is sort of the fundamental building block of any service that the Internet uses, any connection that the Internet has. And you can see on the right here, left here, what is that, right? A model which is often used to represent the layers of the internet. And the shape of that model is really significant because it's very wide at both the top and the bottom, and then very narrow in the middle. And what that means is that at the bottom there, you have the physical layer, and that's really very wide. Internet connections can be made across a really diverse range of physical means. It can go over radio waves, it can go over fiber, it can go over copper wires. At the top again, you see the application layer, and again, very wide, a huge diversity of applications that the internet can use. But in the middle, you have what we call the narrow waist, and that's the Internet Protocol. So while there is this diversity of means to transmit data, and while there is this diversity of applications for it, there is just really one Internet Protocol which defines the internet. So it makes it really important. Now, IP addresses, which I mentioned, basically represent points on the network, and essentially they're just numbers. And what we do with those numbers is register them and make sure that you're using, not using the same number as someone else to define where you are on the network. What complicates the issue a little bit is that there are actually two flavors of Internet Protocol. Now, one of those is called IPv4, and much of the internet that you use or know is probably running on IPv4. And this is the Internet Protocol that was defined way back in the late 70s, early 80s. And it uses 32-bit addresses, which means you have 2 to the power of 32 unique addresses in this pool. And you can see there, it's often written or they are written as 4 octets. So you see an IP address, it's something like 192.0.2.130. Now, that was all fine. This was how the internet grew. This was the basis for developing the internet. But when it was defined, it was assumed, or I guess hoped, that around 4 billion addresses, which is what a 32-bit address will give you, would be enough to cover whatever the internet grew into. As it happened, the internet's growth far outstripped what was expected in those early days. And 4 billion addresses hasn't been enough. We have really a much bigger network now that requires even more than that number of addresses. So this was realized in around the early 90s. It occurred to people that this internet is growing very quickly and we're going to need to have a different kind of address, which gives us more unique numbers. And so IPv6 was developed. And this is based around 128-bit addresses, which means you have 2 to the power of 128 unique addresses, written, as you can see on that slide, as a very, very big number. They're also written differently in terms of how you actually write them down. They're written in what we call hexadecimal. And so it uses colons and numbers and a few letters there, and you can see what one of those looks like at the bottom. The challenge with IPv6 and the fact that there are these 2 kinds of addresses is that they're not actually directly compatible with each other. So whereas we had an internet based purely on IPv4, everything was interoperable, everything could talk to each other. Now we're deploying IPv6, which can't talk directly to that IPv4 internet. So one of the real governance challenges in relation to IP addresses is, how do we manage that? How do we either bring everyone onto IPv6 or find ways to make IPv6 talk to IPv4? And the fact is that bringing everyone onto IPv6 has not been going so great. It's probably going better these days than it was a few years ago. I'll certainly concede that. But basically, for the last 2 decades, there has been a real push to get network operators to start using IPv6, to start connecting people using IPv6. And it hasn't gone so great. A lot of that is because you have some very big networks that are already using IPv4. So there's a sort of inertia in getting people to move. In other parts of the world, there are people using older technology, older routers, older machines, which are set up for IPv4. So then there's that question of a digital divide actually being exacerbated there. This map actually, which is based on some data that APNIC collects, which is an Asia-Pacific Regional Internet Registry. It shows how this looks around the world. And it's a really interesting perspective, because you can see that there are parts of the world where that uptake of IPv6 has been much stronger. And there are interesting reasons for that, which we probably won't get into today. But if you look at something like India, which is doing so well and so far out in front, part of the reason for that is new networks, new particularly mobile networks, which are being deployed and which are just using IPv6. So that's a bit of an illustration of that inertia problem that I was talking about. If you're building out new networks, then you have an opportunity to use IPv6. But how do we bring the rest of the internet along with us? So governance of IP addresses and their registration is an important issue. And the way this has been done since really the early 90s is by regional internet registries. And the RIPE NCC is one of 5 regional internet registries. It was actually the first. It was established in 1992, followed soon after by APNIC in the Asia Pacific, then ARIN, LACNIC, and AFRINIC around the turn of the century, early part of the 2000s. And basically what each of these 5 RARs do is serve a community. And it's important to note that each of these 5 entities that you can see on the screen on the map here represent 2 things. There is the registry, which is what I work for in the RIPE NCC's case. It's called the RIPE NCC. And the registry will maintain a database of who has what IP addresses, and it will make that database public. It will also let people come to the registry and ask for additional IP addresses, and we can provide that. But then alongside the registry, there is also the community. And this is a really key aspect of the RIR system, because the RIR registries themselves don't actually decide the policies under which they do their job, under which they register addresses, under which they hand out addresses. That's decided by the community itself. And so each of these 5 regional communities have a policy development process by which they tell the registry exactly how to manage IP address registration. This diagram, I guess, is a way to try and think about that. So at the top there, you can see the registries, the Regional Internet Registry. You have those 5 there. And we hand out or register internet number resources to our members. And so you can see the membership there in the orange circle. Now, this is the next really important part to remember, is that it's not just that membership who make the policies that tell the RIR what to do. It's actually the RIR community, which includes the membership, includes the people who pay money to the registries to actually obtain resources, but it actually also includes really anyone else with an interest. So that means governments, it means law enforcement agencies, it means the business community, civil society, those with an interest in human rights, and also technical community members. And so all of those people are part of the open communities, which then have to come to decisions via consensus on what policies the RIRs should actually work according to. And this is really important, mainly because it is the multi-stakeholder model in action. This is the kind of multi-stakeholder approach that was developed sort of within the technical community to make technical governance decisions that the IGF and the WSIS process took on board when they first started really working in earnest in the early 2000s. So it's an important model to be aware of and to have some understanding of. I want to go very quickly through this slide just because there is also another layer of policy making there, which refers to global policies. So there are policies that are made for each regional registry by its regional community. It is also possible to make a global policy which applies to all of them, all of the registries. That's done by agreement within each of those 5 communities. So it's actually a very rare and challenging process to get to. But what it shows here, and I want to show at the bottom here, is some of the interlinkage you see between the different organizations. So Adam, who's going to speak after me or after Olaf, works for ICANN. ICANN actually has a role there also in managing the IANA, which is the top level registry of IP addresses and many other aspects of the internet architecture. So mapping how those different organizations work together can be a challenge sometimes, but it's certainly something that's useful to be aware of. So this is my last slide. I just want to go through this a little slowly, or at least in some detail, because this is where you start to see the governance challenges of all this, of how this all applies to an internet governance discussion. Because there are 2 principles that are really key to how the RIRs do their work. One is that you need to have an accurate, up-to-date registry of who is holding what internet number resources, who has what IP addresses. That's important for technical reasons, it's important for law enforcement, it's important for really any number of reasons. So the job of the regional internet registries in maintaining and updating that registry is really important. But then a second principle that the RIRs have, and the RIR system has, is that those policies about how we do that should happen in an open, transparent, bottom-up and inclusive way. And so that's often at odds with maybe what some governments or regulators are used to, or the processes that they would see as most efficient or effective. But when you're talking about a global network, you're talking about something that sort of goes beyond single jurisdictional boundaries. This kind of consensus and transparent and open process is really what's required. And so that's something we talk a lot to regulators and governments about. But so there are significant challenges that come into play in relation to all of this. And the first, and I mentioned before IPv4 and IPv6, the big challenge that is faced in IP addressing is that exhaustion of the IPv4 address pool. So I mentioned that when the internet started out, they figured, okay, 32-bit addresses, 4 billion unique addresses, that will be enough. It wasn't enough. In 2011, the IANA, which is the global highest level of the hierarchy pool, ran out of IPv4 addresses. In the years that followed, the 5 regional internet registries have also run out of IPv4 addresses. Now, what shifted there, and something that perhaps wasn't actually intended to happen in the first place, because it was intended that everyone would move to IPv6, was that IPv4 actually became a commodity. People started buying and selling IPv4 addresses because they were a scarce resource. Now that's changed a bit the nature of the regional internet registry business, because now you have something that's worth money, which is worth defrauding the registry for, which just creates, and you need to have registries who are able to deal with that change, that shift in the market. So that's something that's being dealt with. There's also the slow uptake of IPv6 across the internet, as I mentioned. This is a challenge which has many outcomes. It can exacerbate digital divides. It can mean that it can create challenges for network operators, even in sort of very developed countries and economies. But there is a challenge in how to actually incentivize people to start using IPv6 on the internet. And that's something that the RIRs work very closely with a lot of different interested stakeholders in. And then finally, and this, again, I come back to my point earlier about open, transparent processes. We often now find, as regulators and governments start to take a much more active approach to regulation and to making laws in relation to the internet, that the RIRs and the work that we do can actually come into conflict with local or regional regulation. So either in the country where the RIRs are based, and so the RIPE NCC is based in the Netherlands, and so we have to abide by Dutch law, or we might find that the work we're doing for our members or with our members actually means that our members are breaking the law in their own countries. So that's something that we have to work very closely with to understand and to try and ensure that those situations don't arise, or where they do, that we're able to rectify that situation. So I've got questions here, but perhaps it makes more sense to jump onto Olaf and the next part of this presentation. But I am actually happy to take questions if people have anything of urgent interest that I can address.
Thank you very much, Chris. Let me see. I think I read a question. It was about the difference. Give me a second, please.
Yeah, it was my question, but as I understood, we decided to go to Olaf, right?
Yes, but I think you can ask your question because it's very important to this presentation. Then we can continue.
Sorry, and I'm just finding the chat here as well. Here.
Okay, no problem. Then my question was, you told about your community and you said that there are many participants, but you decided to separate government, law forces, and also regulators. And sometimes I think that we take all these 3 parts as one, as general, as regulators. So my question is, why you decided to separate them?
So, and you're right. I mean, we could just say the public sector. My separating them probably has a little to do with the way that as RIR staff we approach that, because we often find that those different groupings have quite distinct approaches or needs or interests. So with law enforcement, for instance, you'll have a very strong interest in accuracy of the data. Are they able to go to the database and say, this is who has this, and that's correct, and that's up to date? Absolutely, we know that. From regulators and governments or other legislators, you obviously have some concern about that, but you also have economic concerns, how things like lack of IPv6 uptake affecting the ability to develop new networks in their country, and what's the economic impact of that on their citizens, or what does it mean for accessibility of their citizens if they if you know, having to buy IPv4 addresses means the price of connectivity, price of an ISP plan is too high. So yeah, you do see a lot of quite diverse and even sometimes conflicting interests coming out of that public sector group.
Thank you.
And I see Daniel Hyatt has a hand up. No? Yeah. Daniel, if you're speaking, I can't hear you.
Can you hear me now?
Yes.
Okay. So thank you for your wonderful presentation. I wanted to ask a question regarding the global governance of internet. For example, like when you look at internet from the perspective of different groups, like for example, the East versus, or I should not use the word versus, the East and the West perspective. So most of the time, like it has happened that, perhaps that's my personal observation in my community, because I work with the civil society, that usually through the social media platforms, most of the opinions and the perceptions and the culture of the West is kind of imposed on the Eastern, on the Eastern side. I mean, by East, I mean the Asian countries. So like how, from a governance or the policy making perspective, how is that system incorporating or ensuring the inclusive internet and a safe and transparent space for everyone, so that this perception of West imposing their views on the East, especially to the social media platform like Facebook, Instagram, or Twitter, to say like they do not kind of overpower Eastern values. I'm not sure if I portrayed my message in the right way, but just I hope you're getting my point. Like how do we make it inclusive for everyone?
Yeah, and I'll try and answer this quite briefly and quickly. And I mean, I think, you know, if you get into issues of platforms like Twitter, etc., it gets very, very complicated, and I don't have answers for that. But I think you are touching on one of the reasons that having those 5 registries is so important, because there are cultural differences, there are economic differences across those 5 regions. Now, I mean, it's a somewhat arbitrary way to break down the world into 5 regions, and even something like the RIPE NCC service region, which covers Western Europe, Central Asia, the Gulf, etc., the very different areas with very different needs. But by having these 5 regional internet registries, you at least have some way to address the fact that many of these areas are at different stages or have different needs and concerns. So, for instance, the Afrinic RIR is in a quite different situation in relation to IPv4 addresses. They still actually have some IPv4 addresses, but they also have a need to grow networks in Africa, which is at quite a different stage than, say, the RIPE NCC and our service region. So I hope that answered it. It's probably useful to go on to Olaf now, given that I know we want to keep moving.
We can keep moving forever, can't we? Hello, my name is Olaf.
If I could jump in, if anybody else has question for Chris, maybe you can just write it in the chat.
I'll keep an eye on it and answer any questions I see.
And I'm passing the floor to you, Olaf. Sorry.
Thank you, fabulous. So my name is Olaf Kolkman. I'm a principal at the Internet Society, and I will be telling you a little bit about how the internet actually works. And in order to follow this most effectively, somewhere at your top left corner of your Zoom window, you can tell if you want a grid zoom or a speaker view. You want to have the speaker view, because I'm going to draw a little bit on the screen behind me, and that might be helpful. So Chris was talking about IP and IP packets, and he just mentioned that in passing. IP packets are of incredible importance. Suppose you have a message that you want to send over the internet, like that could be a web page, but it can also be a video message or the voice that I'm now recording. then what your computer will do is will take that message and chop it up in little pieces, just like that, just little pieces. And those collective little pieces will go into envelopes one by one called IP packets. And those IP packets will be sent from one network to another network, to another network, to another network, until you reach the destination. Packetizing, breaking up information in tiny little packets and make them find their way over the internet by putting a destination and a source address with them is what made the internet so incredibly successful. That is what the essence is of the IP protocol. And once you have that, you can build all kinds of networks that deliver IP and all kinds of applications that consume IP. That was that hourglass that Chris showed on his slide. The essence of the internet, that essence gives you a number of critical property. The way that the internet has been designed, its architecture, comes with a number of critical properties that when you change them, you end up with something different that is not the internet anymore. And when you change them, you lose a number of properties, a number of results of the internet that make the internet such an incredible tool for social and economic progress. And of course, a tool that also has its own issues, just like with any other technology, when people use it, they use it for the good, they use it for the bad. The technology itself has these properties that makes it global, that makes it innovation easy, and so on and so forth. Those 5 critical properties, I'm not going to explain, but if you Google for Internet way of networking and you add Internet Society, then you will end up at the page where they're described. Now, one critical property is that of decentralized management and a distributed routing system. And it is the distributed routing system and that decentralized management that comes with it that I want to spend the next, say, 20 minutes on. That is the topic of what I'm going to talk about. There's one thing that I want you to take away from all of this. It's one phrase. If you remember that, I'm good. The internet is a network of networks. The internet is a network of networks. If you think about it that way, you can get a long way with understanding what the internet actually is. So, what does that actually mean? A network of networks. Well, you have all kinds of networks, which I draw as circles. And all these networks have their own purpose in their life and existence. This is not a geographical map. This is not projecting a network over a country or something. This is just a network. And a network can span many countries. It can span oceans. It can span all kinds of geographical topologies. But the network is a unit, and it has a purpose. It can have some networks are access networks. Basically, it are the networks to which you now connect with your mobile phone or with ADSL or the fiber line out of your house. Customers, eyeballs, connect to the internet by connecting to one of these networks. Other networks are purely there to transit the information from one from one network to another. They're called transit networks. And usually these are the networks that operate transatlantic fibers and so on and so forth. All in all, there are about 70 current number, about 70,000 independent networks. What these networks do is they take up IP on one side of their network and they spit it out at another side, closer to the destination of where those packets need to go. And how they arrange for their own infrastructure, that's up to them. If they want to build copper lines or build satellite networks or fiber connections or microwave connections or all those kinds of technologies by which you build networks, that is their own decision. They don't need to coordinate that with all the other networks. They only need to connect to their neighbor. So that's actually what happens. These networks are connected to each other in, well, what you could say pretty, in ways that are governed by business relationships. So already I have talked a little bit about decentralized management. There is no central control for the internet to say you have to evolve in this way. You have to make sure that this particular technology is available to all your customers in the next 10 years. No, that just happens. That happens by the virtue of applications becoming available, and consumers are willing to pay some money for those applications to be used. And then the market sorts out how the balance is. That's sort of amazing that 70,000 networks bring this global perspective, this global connectivity, and all manage their own part of the network. Another thing that is something that flows out of this model is that the internet is accessible. It is very easy to build a new network. Let's give this network a different color. It's very easy to build this red network over here. If you build a network, and that you can actually do this, you can go out, build yourself a Wi-Fi network in your region, and or pull some cables, buy some fiber, pull some cables, and connect all your friends, or create a network on the campus. In order to connect to the internet, you only have to find a network that is willing to connect to you and ship all your traffic, all the traffic that it receives from you, to the destination. So the only thing that I need to do is make a connection to one neighbor. At that moment, my new network, A, is a member of the internet, becomes part of the internet. And when people that connect to network A send traffic to the rest of the network, that traffic will end up there. A pays some money to network B, so some money is flowing there, because you pay to give transit to the rest of the internet. What is important here is that network A, say we have networks N, O, and P here at the right-hand side of the graph, that A only has to make a business relationship with B. It does not have to talk to networks N, O, and P. It doesn't have to talk to the other 69,999 networks that are already out there in order to connect. The business relationship is only with your direct members. And if A wants to, it might connect to yet another network. It might connect to C. and pay them a little bit of money to ship traffic to the rest of the internet. And that might be a little bit less money than pays to be, so then it starts to engineer how traffic flows over the internet. Questions so far? Feel free to interrupt me at any point. So there is a very nice sort of magic that allows A to make known to the rest of the network that it is reachable. So A over there can talk to the rest of the internet, like N, like P over here, or like O over here. A, sorry, I'm doing this in mirror image, so it's difficult. A over there at the end, then basically says to its neighbor, hello, I am A. If you want to reach this set of IP addresses, this block of IP addresses, you can send traffic to me. And it will tell that to B. And it will tell that to C. And B and C will tell to their neighbors, if you want to reach A, I know how to reach A. You can send traffic to me. And C will do the same. It will tell their neighbors, its neighbors, you can reach me. You can reach A through me. And then say that we have network D here. D will tell to its neighbors, in this case to N, if you want to reach network A, you can do so because I know that I can send traffic to network C, and they will deliver it to network A. So N will get some information that says, if I want to get to A, I can follow a path through, excuse me, this is wrong, through A, through C, to D, and from N, so backwards. If N gets traffic for A, then it knows I can reach A through N, D, C, and A. Well, it will also get information about the route, as we say, the way that the traffic runs from the network that lives here, say network E. And so it will have multiple routes, and it will choose based on all kinds of priorities what route the traffic will take through the internet. This was a long-winded way to say that the traffic direction on the internet is a dynamic process. It's called routing, and the protocol that I just explained, the method by which the routing is established, namely by basically everybody shouting, if you want to reach that person, you can go through me. It's all kinds of gossip that is shouted across the internet. That protocol is called the Border Gateway Protocol, BGP. So that's a term that you might hear. BGP is the way that the internet figures out how to reach specific destinations. So that if you are somebody connecting to network N, a user, and you those packets, those messages up in packets, network N knows how to send the traffic over the internet to a specific destination. And should it be the case that there is a network failure, a line breaks here, let's do it like that, a line breaks there, then BGP will notice, and it will be and allow you to send traffic through another path to A automatically. There's nothing that A needs to do in order for that to happen. That is how the internet works. The network of networks is a decentralized system that is managed by all individual entities, all those networks. And the routing is completely distributed and completely dynamic. And that means that when there is a failure, that the internet can route around that. And that is essentially all I want to say about routing. This is how the internet is operated on a day-to-day basis. This is what gives you the connectivity and all the limitless possibilities that the internet has to offer. This is the infrastructure that provides that connectivity, the global connectivity that we all use and enjoy on a daily basis. Questions so far? I can anticipate a question, but let's see if it comes up. Has anybody heard about routing in the news over the last few days, few weeks? Raise your hand in the chat if you did. Yeah, Fred, go ahead.
Hello,
Unmute yourself and
good
speak.
morning, good evening to everyone. I'm Fred Kojo Azor for the record. I think I like the presentation so far from Mr. Olaf. Yeah, so I'd want to find out, I think just a couple of days ago, the world experienced for the first time Facebook and the Facebook group of companies, so Instagram, WhatsApp, going off the internet. So at that point, should we say it was because the BGP couldn't recognize them, that's the routing protocol, couldn't recognize the presence of Facebook on the internet? That's how come they went off, or was it purely based on DNS issue or something? I know you are not actually representing Facebook, but just to ask.
It is an excellent question, and just the question that I anticipated. It is actually an excellent question. What you have to know is that if you look at this setup of a network of networks, what Facebook is actually only one network. In the context of a network of networks, Facebook is just one network. Most companies are so small, so to speak, that they don't have their own network. But in this case, Facebook is, in the context of this picture, a network. And what happened is that what they do internally is they use BGP, this gossip protocol that I just explained. They use that internally to tie all things together. But they made a mistake in their configuration. And by doing that, their DNS servers, which are represented on one of these networks, started to say, we're not part of the network anymore. The DNS servers they couldn't connect to some internal networks, and therefore said, we are unhealthy. We are going to disconnect from the internet. We are going to break this connection. So the DNS servers basically said, we don't want to be part of the internet any longer. That is not a failure of the internet. That is a failure of the way that Facebook has architecture, let's make this clear. These the Facebook architecture is incredibly complex. It's really, really difficult. They do enormous engineering work, and what happened to them was, an honest mistake, complexities that trickled down into other complexities, and suddenly their network was gone. But still, this was an issue with their network connecting to the rest of the world. And because the rest of the world is thoroughly addicted to Facebook, people felt that the internet was down. But the internet wasn't down, Facebook was down. Facebook is not the same as the internet. It is an important service that is delivered through the internet, but it is not the internet. You notice that when I say that through the internet, I really am talking about the internet again as a network of networks, which might be a little bit different than you usually talk to about the internet. Fred, did that answer your question? It was I was hoping you would ask it. Thank you very much. But I wonder if it answered your question.
Yes, I think you've answered it very well. And with the illustration that you did, I'm sure the group or participants here are also benefiting from it. So thank you very much. And I like the part where you stated Facebook is a giant network on its own, but it is not the internet. Because, sorry to barge in this, I think when I was writing the paper on the unconnected perspective, that's internet governance, the unconnected perspective. And I was trying to do some little survey. So I asked a few people within my community here in Ghana. And I was surprised when I asked them, what is the internet? The first person responded that the internet is Google. And I was very shocked. I wanted to laugh, but I had to control my laughter because I was trying to speak to someone who had no experience of the internet, apart from the fact that the person I've heard there is something called WhatsApp and other things. Then I got another perspective from some youth who have also been able to, who use the internet on the daily, as in they buy data bundles to use WhatsApp, they go on Facebook, they have Instagram accounts and all that. But these people, interestingly, could not also define the internet or could not give a good brief of what the internet is. So it looks like people on the daily interrelate the definition of the internet itself to the social media platforms that they are very conversant with or presented with every day. And so they sometimes even forget about how the applications that are left on the internet forms a part of the internet and the transport protocols and the other protocols as well. So I think it's a great presentation, and then the question was well answered. Thank you.
Thank you, Fred. And what you share there is an experience that that resonates highly with mine. But I want to be careful for blaming people for not knowing what the internet is. The internet to most people is what they are experiencing when they go online. That's for them is what the internet is. And to give a somewhat a weird example, perhaps, if you go to the toilet, you don't have to know about plumbing. You don't have to know about the sewer system that runs under your city, how the excrements are handled by the municipality, how, you don't have to know that and in order to do your daily business, so to speak. And the same is with the internet. You don't have to know how the internet works to do your daily business. And just like you and me, or at least like me, part of my daily business is Google, and one of the first apps that I start in the morning is Twitter. But I do think, and that is why I like giving these presentations, understanding a little bit about the plumbing when you want to govern things, when you govern a city, it might be handy to know something about the plumbing. If you govern the internet, it's very useful to actually know how it works technically. And that's, I think, for you who enter hopefully a long career in governance, internet governance and other governance, understanding a little bit about what the fundamental properties are of a technology, what makes the technology do its thing in society, I think that is an important thing to realize. So, Alina, I see your hand.
Yes, actually, hi. Question just jumped into my mind. People say that when something is on the internet, it stays there forever. So my question is, can you really delete something from the internet, or you can just disconnect the server forever, or like for some time, and it will actually stay in there somewhere in this whole ecosystem?
I'm showing you a hard disk and another hard disk and another hard disk. I've got a bunch here that just lay here on top of my shelf. And they are here because I have not wiped them. And so there's still information on that. And that's sort of how the internet works. It often is more expensive to wipe things than just keep it around. And it might be still around and unfindable, but wiping things is actually an expensive proposition. I hope that answers your question very shortly. I think there is a longer answer to that, but I don't want to eat away from Alan's time. Over to Alan directly. Go ahead, Alan.
Yep, thank you very much, everybody. Thanks, Olaf. That was really interesting. Fred's point about asking people who, what you think the internet is. I remember 2012, I think it was. I remember way back then when I was giving a lecture, remembering that 37% of Italians in 2012 thought the internet was Facebook. So it is still very much what it is. Let me see if I can share my screen. I'm not always very good at this. And where is it? I hope you can see that, and I hope it's sharing correctly. So what I'm going to talk about is ICANN, the DNS, and maintaining the unique global network. So this is really the sort of user interface to some of the things that Chris and Olaf talked about, the technical underpinnings of this network. And really, it's all about how do we map internet protocol addresses to domain names that each of us can remember. If you type 192.0.43.22, which, as Chris said, is an IP4 address, IP version 4 address, into your browser, it will resolve to www.icann.org. And even if you can really type those IPv6 addresses into your browser, they do the same thing. But the idea is you're not going to remember these series of numbers, but the alphanumeric strings that we see in domain names are memorable, and we use them. So it's about the human interface with the technical underpinnings of the internet that we've had described. It's also important that the domain name system is something of a constant, in the sense that if you think about Google.com, you might have started using the internet in 2008, and in 2008, you would have typed in Google.com. But think about the network that's developed behind that name. You don't have to worry about that. You don't have to worry that all the services and things that Google have added. What you have is a very simple interface into all of the structures that are and information and so on that are on the internet. So that, I think, is a very important point that we have to think about. Also, we're talking about unique assignment. And while Olaf spoke about this massively distributed network, when you're thinking about unique assignment of names and addresses, then it has to be unique or you'll end up in the wrong place, right? You can't have two ICANN.orgs, one with information about ICANN and the other with information about the ubiquitous internet cats. You want ICANN.org's information. So it has to be uniquely assigned, as do internet protocol addresses. And that means within this decentralized network, you're having a centralization of some allocation of resources. So it's quite unique and very important because of that. Let me see if I can go, oops, jumping ahead. So we've mentioned that, let me just see if I can just adjust there. There we are. So the internet is a mesh of networks whose operators agree to communicate using this predefined set of protocols, TCP/IP suite of internet protocols. These are defined by the Internet Engineering Task Force in a set of documents which provide the sort of user manual to the internet. Protocols are the rules that allow different components of a communication system to communicate, the instructions that go across this network. So it's the assignment of protocols. Networks, as I said, use identifiers, are identified by names and numbers. Individual computers, every device on the internet will have some form of internet protocol address assigned to them. And at ICANN, we see these internet identifiers as being names, domain names, numbers, and protocol parameters. And as I said, they must all be uniquely assigned. This is another way of saying that. You can see the IPv4 and IPv6 addresses that are used for the machines and devices on the internet. People need to use names, and mapping these IP addresses to names is called name resolution. So resolving the names that, or resolving the IP addresses, which identify the devices on the internet, and then the names that you use to access them. So this is a very typical domain name, right? It's the type of thing you will see in your web browser, and it's the website for the Internet Governance Forum. Interestingly here, we actually read this when we're talking about name resolution from right to left. So you begin with something called the root. But of course, when we're thinking about it, what we're trying to access is that information that is located in this case at www. So we think about it about left to right. So let's look at what the components of this name are. We've got HTTPS, which is the Hypertext Transmission Protocol, secure, because in this case, the information is being encrypted, so it's passed securely. But you'll also see HTTP, of course. And this is the protocol that governs how information is sent from the desktop, from the website you want to get to your own device. And those are the rules that judge that. www is the web server, and that's the information, that's where the sort of database of information is held. IntGov Forum is the second level domain name, and this is something that you and I and users, in this case, Chengetai Masango, who many of you will know because he's the manager of the Secretariat for the IGF. He is, I think, the owner of or he holds that domain name, and he registered it. And we all can register second level domain names. .org is a top-level domain name, and these are the databases where all of the second-level domain names, the information about those second-level domain names is held, and then the root is where information about the top-level domain names is held, the IP addresses, so that we can access those when we do domain name resolution. I'm not going to go into too much information about domain name resolution because it will take too much time, but I'll give you a link to a very useful video by an organization called Center, another of our partners with the RARs, Chris, and Internet Society, Olaf, representing the country code top-level domain name. So I'll send you that link in the chat. This is what it looks like when we see the domain name system as a hierarchy. As I said, it's an inverted tree structure, really. And whenever you want to climb a tree, well, think of it upside down. You begin with the roots and you climb upwards, because our destination is actually that information we want to get that we see in www or mail. So as I said, what have we got that's represented here? We've got the root, and the root server contains at the moment, I think, 1,589, or the information about 1,589 top-level domain names. So it's the Internet Protocol addresses and other information about those top-level domain names. And then at the next level, you can see .coffee, which is an example of one of the newer top-level domain names. .com, which many of you will be familiar with. It's a legacy name that's been around for 20, 30 years. And then the XNJ6, etc., etc. That's actually a code, and that represents Hong Kong when it's translated into the web browser representation. That is actually a Chinese character script that you would see the name for Hong Kong. But in the name system, it's actually represented by a code. But anyway, don't worry too much about that. There's a much longer presentation about internationalized domain names, which are very important for bringing other countries, other language scripts, the content from other language scripts into the internet. And they've been going for about 10 years now, and a very important project of ICANN and others. So what the top level nodes, what the databases here contain, is all the Internet Protocol addresses and other information for the second level nodes, or the second level domain names. The example you can see, foo, bar, and example. IntGov Forum is another example of a second level domain name. And these are the things that we register. So there will be some 350 million of these these second level names within the databases of the top level domain name structure. And then below that, and this is important because these are all locally maintained. So if you're, for example, if you're the person who's registered example.com, you can decide what information and the structure you have below it. It doesn't have to end with www or mail, www, where you have all the information you want to present to the world. It can be much more complicated than that. And so if you look at something that may be familiar to you all, Europa.eu is the domain name for the European Union. And what they've done is instead of having www, the example here I'm showing is ec.europa. And what they're doing here is that's the European Commission. So one of the substructures of the European Union. And then you can see digitalstrategy.ec.europa.eu. That would be a fourth level, and that's where the digital strategy directorate, or the directorate that's responsible for digital strategy in the union, is representing its email. So the structure of the domain name sort of space can give you different ways of representing content and different services. As I said, the resolution happens because basically it's a lookup system. In the model example, it involves you when you type in, for example, www.intgovforum.org, that will query first the root server to say, through a system of services called resolvers, which are available on the internet and are embedded initially within your laptop or embedded within the services of your phone or other device. It will query the root, which will give you the IP address of the top level domain name database you need, in this case .org. You will query .org, and that will give you the IP address for intgovforum.org, and then you go to the name servers that have been set up by Chengetai and the IGF Secretariat, and they will give you the IP address for whatever service it is you want. It's complicated. I'll send you a video because it makes it a little bit easier to see. So, I don't know if sorry. The importance of the root zone file, and the root is this is the essential information of the internet. All of the top-level domain name servers query the root zone file every 2 days, every 48 hours, essentially, to refresh and update the information they have to make sure that the information we have is always up to date. There are 13 identical root servers managed by 12 different organizations. And it's not actually limited to 13. There are actually at the moment 1,467 instances, i.e. perfect copies of these root servers. And these are distributed around the network that Olaf described. So they'll be closer to you. So you don't need to access the 13. You can access their perfect instant copy wherever would be easiest and closest for you. ICANN, I think, as Chris mentioned, is the operator of what's called the IANA functions, and these include the management of the root zone database. So IANA is where you go to if you need to update any information about a top-level domain name. And it's interesting from an internet governance point of view, because until October the 1st, 2016, that's 5 years ago, so we're in our 5th anniversary just, this function was actually managed by the US government. It was a legacy of the evolution of the governance system, of the sort of evolution of the internet, actually. And this was transitioned over to ICANN, but also with important oversight from the RIRs, Chris's group, the IETF, which is one of the world's leading internet technologies Olaf is very involved with. And so we have a representation and an accountability mechanism to make sure that ICANN operates the IANA functions correctly. And this whole transition process, setting new policies for the root zone, by the ICANN community was really an excellent example of multi-stakeholderism in action. And this is one of the most important things about internet governance is we're talking about multi-stakeholder processes, whether it's the Internet Engineering Task Force developing standards, the RIRs with their network of people coming together to develop their policies, or in ICANN. And I'll go into the ICANN example a little bit more detail, but first, this is the sort of business arrangement that we see in ICANN for what the domain name system looks like. And this is the sort of whole business area or functional area that ICANN deals with. A registry is the database of domain names and registrants, top-level domain names like .com, .org, .coffee, .nl, .pl, .tz, and all of the country codes and so on, 1,500 or so that I mentioned. Registrars are the agent that acts between us, the example of Chengetai again, or whoever it is that holds ICANN.org, etc., where we go to make the contract to become the person who operates int.govforum.org, for example. These registrars may have a reseller agreement with others. These registrars tend to be hosting providers, they can be ISPs, or it might be a company that's independently set up to organize the domain name sort of service. And then we have registrants, which is you and me, people who have a domain name, hold a domain name, and make our content available, our services available with a website using that name. From an ICANN point of view, we see the registries and the registrars as contracted parties. To become a registry, you have to enter a contract with ICANN. To become a registrar, you have to enter a contract with ICANN. And the policies for this are developed through the ICANN community. So there are accreditation agreements if you want to be a registrar, and the policies that go into that registration agreement come from a community bottom-up developed process. The same with registry agreements. These are developed through processes that involve the community. And so are the agreements that basically function around this. and this is really a really very key part of what ICANN is doing. So the other part of what we do, well, we've got here policies that govern the contracts between ICANN and the registries and the registrars. These can be consumer related, giving you protections about how you as a registrant have your domain name, rights protection, because we don't want people using a trademark inappropriately on the internet, trying to represent a brand or a person or something, and many other issues around rights protection, and then technical standards, operational standards that the registries and registrars must meet, and much, much more. And then the policies also look at the organization of ICANN. And these are about the budget that we have, the strategic plans that we have. These are, of course, interrelated. And these are developed through input of the community and actually in the accountability and transparency mechanisms. Should something go wrong with that process, should, for example, ICANN board of directors ignore what the community is telling it about how the budget should be structured, then there are accountability mechanisms that can force the board to actually listen to what the community is saying. These were developed during the transition process I mentioned that completed 5 years ago in October the 1st, 2016. There are also policy processes, review processes, where we look at how the organizational structures work. Are they all operating efficiently? And I'll talk about some of these in a moment, but the structures I'll mention in a moment are all reviewed for their efficiency and efficacy and so on. We also review how different operations work, and so on and so forth. There's a very complicated set of policy discussions ongoing in ICANN at any one time. And we very much hope that you guys will come into the community, but it is a little bit overwhelming at the first because there is so much going on. And as I'll mention right now, the structures that you can be involved with, and you can be involved, this is very important, they are also complicated, but you get used to it. And I used to be a community member and I rather enjoyed it. Now I'm a member of staff and I still enjoy it. So at the heart of ICANN is this multi-stakeholder model of policy making. It's a decentralized governance model, placing individuals and the industry and commercial interests, non-commercial interests, and governments, importantly, on an equal level in the policy development processes. And these are mandated within the bylaws to ensure that there are ways to prevent capture, because we understand different voting levels and so on. The contracts and policies are developed by community processes. As I said, it's bottom up. And what that means is that new ideas for policy improvements can come from any individual. So it's not necessarily coming from a top-down mechanism. It can come from anywhere, and particularly emphasizing the bottom-up inclusive nature. And decision-making is by consensus. So we have to reach agreement to make sure that we can go forward. And in this way, sort of the internet governance structure mimics the way that the internet works, which is collaborative and borderless, as Olaf was explaining, and open to all. You just come in and follow the protocols, and you participate. There are two different structures for how we bring the community together: supporting organizations, and these are responsible for developing the policy in the areas they represent. Chris mentioned something called the NRO. We also see that as an organization we call the address supporting organization, for example. So Chris's colleagues are responsible for global policy around internet protocol addresses, and they come together when they want to organize something at the global level. They are the policymakers in their respective areas, but they may come to ICANN to get some global consensus about how to move forward. And I'll mention some other supporting organizations, and then advisory committees which advise on policy development processes, and they can also advise on other policy that ICANN may be thinking of. So quick look at what it looks like in this sort of diagram. We have a global multi-stakeholder community of volunteers. There's the directors, the board of directors, and these are all representatives drawn from the community. And what happens is that the policy is developed in the multi-stakeholder community. It then goes to show that the board of directors will then look at how that policy was made. Did it follow the sort of rules-based and well understood policies? Did it tick all the boxes in its policy development processes? Is it appropriate? Is it going to be budgeted? And then the directors will agree on the implementation of policy, which is handed over to the ICANN org, which is the ICANN staff. And our role is to implement and help the community implement policy. And we also support the community in its policy development work. So we have a dual role in implementation, but also supporting the ongoing work of the global community. The structures look like this. We have supporting organizations and advisory committees, as I mentioned. The board is taking its members from the community, and then the organization has its role. These are the supporting organizations. The address supporting organization, as mentioned, Chris mentioned it as the NRO, the number resource organization, and they are responsible for bringing expertise about internet protocol addressing into ICANN. And they develop policy at the global level within ICANN using the ASO NRO structure. The CCNSO is the country code managers. So there are, I think there's 200, I forget how many there are now, 250, 280 country code managers, because some of them, sorry, there are not that many. I'm confusing internationalized domain names. I was confusing the number of country code top level domain names. There are about 170 country code managers, and they participate through the country code name supporting organization. They develop their policy at the national level because countries are sovereign, of course, but they come together in ICANN through the CCNSO to develop policies that need to be global. For example, standards for internationalized domain names, where we're developing new standards and coding systems to help represent different scripts and languages. And then the GNSO, which is sort of the workhorse of the ICANN policy development process, because it's the generic name supporting organization, and these develop policies for all the generic top-level domain names, i.e., all the top-level domain names that are not country codes, com, .org, .net, and then all the new TLDs that you may have seen. TLD is a top-level domain name, I'm sorry. We talk in acronyms a lot in ICANN. So all the new top-level domain names, .shop, .amsterdam, and there are many, many, many of them. So all of those policies are developed by the generic name supporting organization, and they go through processes to be evaluated by other groups, the advisory committees, and then eventually going to the board. 4 different advisory groups. The at-large represents the interests of individual internet users, bringing a perspective of users into the ICANN policy development process. The governmental advisory committee, just because we're multi-stakeholder doesn't mean that governments aren't involved. Of course they're involved, they're a critical stakeholder. There are now 179 member governments and 38 observers from international organizations involved in the Governmental Advisory Committee, and they bring a very important perspective on public policy issues, particularly how they interact with policies and national laws and international agreements and so on. The Root Server Advisory Committee advises on the operation of the root server system, which of course is essential. It's only those 13 members, 12 member organizations. Interesting thing about the root server system is that, it's 38 years old now, essentially, since the first ideas about how the root servers would work, 38 years, and the system has not had one moment of downtime in those 38 years. Incredible robustness you're seeing in some of these core operations of the internet. And then you have the Security Stability Advisory Committee, which advises on issues of security and integrity of the naming system, ensuring that we do have robustness and secure naming systems and so on. I think that's me finished, and Thank you very much. Love to hear any questions. And I'm sorry, I wasn't looking at the chat because it was getting in the way of my slides. I didn't design my slides very well. So thank you very much.
Yeah, I just would like to add, thank you very much for this presentation. I would like to add that we are running a bit out of time, so we'll have time for 2 quick questions or 1 longer one. So please go ahead if you have any.
Sorry, I've lost how to stop sharing. I've lost my, how do I stop that? Which you don't need to see. There we are. Good, back to Olaf, much better, much improvement on me. So, so if there are any questions, I think the point I would like to say is that, you know, there is a point of control here in the decentralized network, but it's multi-stakeholder, it's inclusive, and it's global, going to an earlier point about inclusivity in governance. The RIRs, as the regional internet registers, as Chris said, are organized through 5 regional structures. ICANN has offices around the world that involve our, you know, different regional community members. We also have, and we make very careful inclusion for different governments. So as I said, there's 170 or so of those. And really the whole point is that it's open to you and open to anyone. And we have different methods of supporting younger people coming into the processes and so on. So it's a globally inclusive multi-stakeholder process, and that's something we, and I know the RIRs and Internet Society work very, very hard on. See a question, Fred, hi, or your hand.
Yeah, hi, Adam. This is Fred for the record again. I think I like the presentation so far. Personally, I'm a member of the at-large technology task force convened by Judith Hellerstein. So I've been following the processes a bit. Can you please, let's say, for the purpose of this group, illustrate how the top-level domains and then the generic top-level domains and the country code top-level domains find itself in the hierarchy that you illustrated initially, because it looks like you focused more on the top-level domains without looking at the other level of domains that are inclusive.
Yes, I think I understand what you mean. So in ICANN, we treat all top-level domain names equally, of course, and so country code top-level domain names, which would be, you know, as I mentioned, .pl for Poland, .nl for the Netherlands, where Olaf and Chris and I all happen to live, or the .uk or .tz and so on. We don't treat them any differently, but we develop policies differently for them. And because the policies for the national operation of, for example, .pl is something that the people of Poland should decide, not the global community. Many of the national policies are developed at the national level. It's a sovereign right of countries to do that, I think. But when they need to come together to develop a global policy, ICANN is used as a forum for that. And also they have members of the board, they can participate, they have representatives on the ICANN board, and they can and do participate in our policy development processes. So country code managers come into all the other policy processes and bring their knowledge and expertise and local views into those policies. We tend to focus a bit more on generic top-level domain names because these are things that ICANN exclusively manages. We don't have to, you know, we don't have that sovereign element of the countries involved. So for example, in 2012, there was a process to introduce a lot of new top-level, the generic top-level domain names. You may have seen them around like .shop, and there were 1,500 of these new top-level domain names introduced in total, I think, now to about 1,400. And that was an ICANN process because it was at the generic level. So there's a bit more concentration on policies at these generic top-level domain names, the .com, the .net, the .org, but we bring in an inclusive community from around the world. I hope that covered what you were getting at.
Yes, I think it's okay for me, and I'm sure some of my other colleagues would understand as well. Thank you.
I see a hand from Vincent. Hi, Vincent.
Okay, I'm sorry because we are
sorry.
a bit, because we are a bit out of time. So I don't know if other participants have a possibility to stay longer. You can just write yes on the chat or no. Because if we just don't want to keep you too long, as I know that it is a very interesting discussion. So yeah, Vincent, if maybe Adam, you could give any contact to you so Vincent can ask you his question. Yeah, it would be great because, as I say, we are almost 10 minutes past time and some people may have other obligations.
Two things I would like to mention. So my email address is there in the chat, adam.peake@icann.org. And I put two links in there. If you save the chat, I think we have the save chat option. One of them is a presentation that is from Centre, the European organization that represents country code top-level domain names, and it talks about how DNS resolution works. So what happens when you type in the name in your browser and what happens to retrieve it from the root server system, etc. And there's also a presentation a colleague of mine gave last week about how the root server system itself operates. And because this is so central to how the internet operates, I think it's a really interesting presentation. It's very clear. And the good thing is it's only about 25 or 30 minutes long, so it's not too bad. So anyway, thank you very much, Amelia. Thank you very much, everybody.
Thank you very much, Adam, and thank you very much, Chris and Olaf. I think that was very interesting, and it can be seen how much questions are from participants, and I think that we could have much longer discussion. And now I regret a bit that we planned this meeting only for an hour and a half, but we can learn from it for the future. So thank you one more time for agreeing to speak for us today. And if I could ask you all to turn on your cameras right now. So I will take a group screenshot. I should have done it before when there were more people, but I always forget about it. Okay, just give me everyone a moment to turn on their cameras.
I have to say, I like Mac Andrea's background there. That's very good.
Thank you.
Yeah, a bit like Christmas. Okay, so I think everybody who wanted to turn on camera is on, so please. And one more. And one more, just in case.
More than 3, and you have to start to pay, Amelia. You know how it works.
Okay, thank you very much. Thank you very much for finding time to join us. Thank you to our amazing speakers. And I hope you enjoyed it. I enjoyed it a lot, and see you soon.
Thank you very much. It's great. Thanks, Amelia. Thank you, everyone.
Bye-bye all.
Bye-bye.
Thank
Bye.
you. Bye-bye.
Thank you, everyone.